Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and this week I want to talk about the types of loads in a building. The space cooling load is the rate that you have to remove the heat from a space to keep it at your desired conditions. It's basically how much cooling you need to keep it comfortable. There are a lot of things in a building that contribute to the space load. The lights in the space, computers and other equipment in the space, and people in the space. You may also have a solar load coming through windows, or conduction coming from the outside of the building. Give myself a little more room. You may also have conduction from interior spaces. There's infiltration, which is air coming into the space through a door or small cracks in the building. Then your ventilation air will also add to the load if it's warm and humid. And then your HVAC equipment will also produce heat. Now the ventilation air and the heat from the HVAC equipment won't actually be part of your space load, but they will be part of your total building load. You also need to know if the loads are sensible, which raises the temperature of the air, or latent heat loads, which raises the water content of the air. Think of it as humidity. The lights don't raise the water content of the air, so they're just sensible loads. The equipment could do both, like maybe a coffee maker would put humidity into the air. People are both a sensible and latent load. Solar radiation is sensible only. Conduction, both of these are sensible. Infiltration will be sensible and latent. Ventilation will be sensible and latent, and the heat from the HVAC equipment will be just sensible. So ASHRAE has a bunch of tables and equations for calculating each of these types of loads. Now I'm not going to go through each of these calculations today. Maybe we'll do that in a future podcast. But to determine the total load of the building, you just add up all of the sensible and latent loads from these different components. So let's just make a little more space so I can talk about airflow. In the last podcast, I talked about the load equation. So Q equals 1.085 times CFM times delta T. So you can calculate how much airflow you need once you know the loads, Q. So CFM equals Q divided by 1.085 times delta T. So let's say that we've got a total load in a building of 95,000 BTU. And you're supplying 55-degree air, and you want your space to be 75 degrees, so that's 20-degree delta T. And you do the math here, and that comes out to 4377 CFM. So you need about 4,400 CFM to handle the load of this space. So that's a quick overview of the different types of loads in a building and how to use them to determine how much airflow you need. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.